Yeah, hey guys. I'm making a little video on the parts and the little system that I put together that allows me to use a three-phase compressor with a AC drive, a frequency drive, in my home shop. Um, I'll do this in a couple little sections, and I'll just put the little video sections together. But first, a little safety warning. The this this is a prototype, and the there's electricity involved and air pressure, and so it's I'm aware of the dangers that are involved here, but I want, if anybody watches this video, I want them to be aware that they have to be very concerned about the dangers that are involved here. So, and another thing, I did a couple drawings for myself, and these drawings are meaningful to me, but I'm not an expert. I'm not an engineer. I'm not an expert in drawing schematics and whatnot. So the drawings were only for me and my use, and I wouldn't want anybody to rely on my drawings that I use for myself and put their safety and risk their safety on my drawings. So with that said, this system is pretty cool. I'm really happy with the way things turned out, but I couldn't find any information on how to do this because it's not out there. I had to basically put this system together myself. The different parts were out there, but like I say, this is probably the first video on YouTube that shows the parts and the system and how it works. So what we have here is we have a low voltage pressure switch. This it's a 4-wire. Actually, I had to buy the connector elsewhere because the connector wasn't available where I bought the pressure switch. It's a 12 millimeter 4-pin connector cable. I built this little relay board. It was really necessary to make this project happen, and it's really simple. I mean, there's nothing to it. There's just a relay module and a couple connectors for the voltage, for the power. This was my early prototype, and this is a relay. This is an 8-pin relay, and it does the same thing that this is a signal press. This is a signal relay, technically called a signal relay, and it's the same thing. Any little relay can be used, and my very first attempt, I used a breadboard with, but the wires were always coming loose and whatnot. So I went to this, and then this is my my final product here. An ATX power supply came out of an old PC. I don't know anything about Apple's, so I can't say that Apple has the same type of power supply. The Dell computers do not have this kind of power supply. They have their own proprietary power supply. This has got the 24-pin wire, and this is really cool. I found these at Amazon. These are ATX power distribution boards, and they break out the power from the 24-pin connector, and they break it out to -12, +12, 5, and 3 volts. I attached this distribution board to the ATX power supply because I'm going to put that into a little fixture, a little enclosure when all is said and done. And so we have the little relay module, the ATX power supply, the ATX power distribution board, and the low voltage pressure switch. Now this is the ProSense PSD25 pressure switch, and what it is, it's basically really cool and really simple. Low voltage power, 4 wires, power in, plus, negative, 12 volts, and then it has two signal wires that that are coming out of that switch. And I'm only using the one signal wire, the normally closed, which will then I'll put this together in another video on how it all comes together. So there's, and I'll go through this drawing. So these are the parts for the to allow me to use a three-phase compressor, a Quincy, really cool old Quincy air compressor, in my home shop using a frequency drive to power that three-phase motor. So I'll pick up and stitch another video right to the end of this video, and I'll return in just a moment. Yeah, hey guys, I thought it would be kind of helpful to describe more information about this little pressure switch and the old pressure switch that I took off the compressor. The reason this old pressure switch doesn't work for me with the variable frequency drive is that in a three-phase system, this pressure switch would have gone into a mag relay or a starter relay in the three-phase panel, and this three-phase pressure switch would have been cycling the three-phase motor on and off depending upon the pressure settings that were set on this pressure switch. And it works great in a three-phase setting, but I don't have genuine three-phase. I'm using a frequency drive, and which is creating a three-phase power source from 220 from the shop. So this wouldn't work the way I use my frequency drive, because I use that frequency drive with a Bridgeport mill and a vacuum system and a dual bandsaw. So this wouldn't work. So I had to find a low voltage adjustable pressure switch that I could use an interface with the frequency drive and the compressor. And this is exactly what I found. I didn't have the language. I didn't know exactly what terms I was using, but I did finally find what I needed. And this is like I say, this is a four wire cable. There's the positive and negative, the low voltage 12 volts to go into the pressure switch. And there's two signal wires, a normally closed and a normally open, that are coming back from this pressure switch. And that I'm just using the one signal wire, the normally open, which then I'm using in the relay board to turn on, basically to run, to push, to act as if it's running, pushing the run button on the frequency drive. And I'll explain that more later. So this has settings for setting up the pressure. I think it goes from like 7 to 110, 120. And so it has the initial setting, the high setting. And then when the air is used and drops down, it has the reset value. So this is exactly what this did, but it works for me in the system that I needed to put together to get this to work. So that's a little bit more on the switches and why I had to go with a different switch. And I just couldn't use that existing pressure switch because of the frequency drive, and I couldn't put it on the back side, on the input side of the frequency drive, because I'm using the frequency drive with other equipment. I couldn't put it on the outside, on the outsource of the frequency drive, because I'm using that frequency drive with other equipment. So this is so I'll splice in another little section of this video in following up immediately. Yeah, okay, this will be the little video segment on the AC drive. I bought this quite a few years ago to use for powering up the three-phase Bridgeport mill. And then I've added a couple of other three-phase pieces of equipment to it. I've added a dual bandsaw and a three-phase vac system, shop vac system. And it's just a matter of changing the settings on the drive for the different pieces of equipment. There's basically 4 main settings that have to be changed for each different piece of equipment. And I've been using this drive the way most people use their drives, using the buttons and the switches and the features on the front of the drive. But there's a lot of advanced features on this drive that I never explored, I never got into, but I had to get into for this project. For this project, I had to use the terminal strip, which I'd never used before on this drive. And then I changed the configuration so that the run button was no longer working on the face of the drive. And I made the run button work off the terminal strip so that when these two wires connect and touch, it's the same as pushing the run button. So I'll do that real quick. And the compressor just started right up. And this is how I've been using the compressor. Well, I'll get into that later. So most of the advanced features, all these features on the front, stop, up, down, speed, they can all be set to operate from the terminal switch. So the only thing I'm doing is I'm just using the run feature on the terminal switch for this project. And this was kind of like the one of the main key points that I had to be able to make happen for this system to work. Because before, before I put the system together, to use that compressor, I would have to push the run button, and I would have to watch the pressure build up in the tank to 70 or 80 pounds, and I'd have to shut off the drive, and that was the only way I could use the compressor. But now with this system that I've got going here, everything's automatic, and it's working. The compressor is working exactly like a compressor is supposed to work. It's automatically filling up, shutting off. As the air gets used and the pressure decreases, it'll hit a point where it resets and turns back on again. So this was really the key with that pressure switch being the heart of the system. This is the brain that has to be done. So what I've got here is these two white leads I've been using. I hook these white leads up to these two jumper wires that jump out the run button, and these go over to the little relay board that I built for this system. So that should explain, and here we got the 220 coming in, and then the three-phase L1, or actually T1, T2, and T3 going out to the three-phase motor on the compressor. So that should provide enough information about the drive part of the system. And then I'll put all the wires together, and I'll turn the system on for the final video. Yeah, okay, so this should be the last little segment on how to use the three-phase air compressor with a frequency drive in a home shop. Everything's wired up. Everything is ready to go. But before I go on, I should say a couple things about the safety again. This compressor is being serviced. I'm working on it. So I'm aware that a lot of things that would normally be safety issues are not safety issues because I'm servicing this compressor. I'm aware of it. I want anybody watching this to know that this is not a safe condition to use a compressor in. I've got wires that are exposed. The flywheel isn't covered with the safety shroud. It's on wheels. So yeah, I know. I want people to be aware. And another thing, this compressor is really interesting. I bought this at an auction. There was just one crappy photo at the auction website. And I couldn't, this was a strange looking compressor. And the reason it was a strange looking compressor, I didn't know until I ended up going to pick it up, and I realized I had just bought two compressors. This compressor is actually two complete Quincy 216 systems that are side by side. There's the other one. And they just share the common tank. And the idea behind that is if one compressor needs to be serviced, the other one's available. So real cool. But I didn't know until I was there to pick up the compressor that I realized I was picking up two compressors. It was really cool. They both work great. This compressor has got the 1.5 horsepower GE 3-phase motor. That other compressor's got a 2 horsepower Dalton 3-phase motor. And so yeah, interesting. So about this system, everything's wired and ready to go. The run button on the frequency drive, that is wired to this relay module. Let's see if I can zoom in on it here. On the normally open side, okay? So what that means is when I turn the power on here, the pressure switch is going to be sending a signal to the relay module saying that I need air. It turns on, it goes and turns on, it pushes the run button, it activates the run button on the drive. So that's the wiring. So let's get this going. And it's really amazingly quiet. It's a great system. It's got a lot of air pressure, a lot of power, a lot of capacity. Quiet, just really quiet, impressively quiet. And so when the system's running, the relay module, the red light is on. The pressure switch has got a little green light, a little green LED that's on. Now right now the pressure switch is set for 25 pounds and 20 pounds to reset. It'll only take a couple of minutes to get 25 pounds. So I'll go through that. I'll go through that drawing again. Make sure that what we have is the pressure switch. Because it's below the shutoff value, it's sending a signal out to the relay circuit board. The relay circuit board opens, which basically activates the run button on the AC drive. The AC drive sends 3-phase power down to the motor, and that 3-phase power going to the motor is going to continue until the pressure switch reaches its 25 pounds of pressure. Then this signal wire gets shut off. There's no more signal wire through there. That and the relay circuit board will then close this connection, shutting off the AC drive. No more power to the motor. So it's a really, it's a great system. It works fantastic. I usually have had it running at 70 pounds and 90 pounds on the tank. It works fully automatic. Works perfect. I've had it running for days on end with no issues whatsoever. This should work and solve that mystery. There we go. The yellow light came on the pressure switch. The motor is shutting down. And we are at pressure on the tank. So that's automatically shutting down. I can probably open the valve real quick and let the air out, and then it'll recycle real quick. Just let's do that real quick. And there it did. It just fired right back up again. So that's the system. I hope if this has been helpful. Leave comments or questions below. I will answer questions about this system and the circuits involved and the components. I won't answer any questions about setting up the frequency drives or the AC drives. General electricity, I won't get into answering questions about that. But any questions about this system and these components, I'll be real happy to talk about. I gotta say, I can't say enough about the automation direct pressure switch. It is the heart of the whole system. There we go, we're just shutting down the system. And everything just happened automatically again. So, hey, thanks for watching.